All right. So answer that question. I hit the record. We'll give people another minute or so to come in. Uh, what's new? How's it going, everyone? Sorry for canceling at the last minute last week.
I hope that worked out.
It worked out okay. Yeah. Um, I thought it was a battery problem because it had died like the day before, and I took the battery out, took it to AutoZone. They tested it. The battery was bad. It was like 7 years old, and so replaced the battery and thought we were good. But he was driving around, died again. So it's the alternator this time, and so he died in the middle of the road. And so I went and pushed him off to the side, and it's being taken care of. But yep, things happen. Well, let's see. I'm already recording, and it's 3 o'clock, and most people have popped in. Maybe a few others will pop in. But other than missing, well, we missed last week. Uh, does anyone have anything new, exciting they want to share? If not, we'll dive into the activities. All right, nothing new and exciting going on in your lives. All right. Let's see. So I'll share my screen. Okay. All right. So in the email that I sent out 2 weeks ago, and I sent out again this morning, there were four links, four files, FITS files, Uranus, Neptune, Mars, and Venus. And if you haven't downloaded those, you should go download them now. They're not, well, they're normal size. So the previous time we met, we were in module 1D, and we did the percentile photometric combination, which is the simplest. It just assumes that the brightest thing in the image is white and then assigns all other colors relative to that. And it's the simplest thing to do. And we used that for Jupiter and Saturn. I think we did Jupiter and Saturn that week. And, that's the best we can do with those because those planets are so bright. And same is true for Mars and Venus, so bright that we don't get any background stars. And ideally, the way you want to calibrate is using background stars because all the stars have been cataloged now. When I started at Chapel Hill, that wasn't the case. You still had to, if you wanted to calibrate something, you had to also go shoot a Landolt field and take the calibration stars there. But now the whole sky is calibrated. Thanks in part to APAS. We'll calibrate to APAS stars, and the Southern Hemisphere APAS telescope was in one of the prompt domes, so we contributed to the calibration of the whole sky. Anyway, um, normally you have stars, and we can calibrate to them because we've measured, the catalogs have measured their brightness in red, green, and blue. But with the bright planets, we don't have that. With the moon, we don't have that, so we use the percentile. And it's the percentile, it assumes the brightest thing is white, and that's pretty close for the moon and for Jupiter and Saturn, except when you're edge on. The rings are edge on right now, and so I learned it actually gotta have a little bit of ring. The rings are the bright white part of Saturn. Without that, it takes the butterscotch planet and just makes it white. So this year, percentile isn't perfect for Saturn. Um, And it does okay with Venus as well, but there's a little catch with Venus being so bright we saturate in one of the bands. We'll deal with that today as well. Anyway, percentile works for those things. The rest you want to do photometric. And we're on the planet, so in this module, we use Uranus and Neptune to transition to the photometric technique. From the percentile which we started with the moon, this module is like a transition to the photometric technique. And when we met before, we learned how to do planetary alignment. And when we were doing the moon, we did feature-based alignment. The planets are too small, we can't do feature-based. So we did that kind of one-click alignment. We took our typically 30 images and clicked on the center for each of them aligned to that click point. So you do the same. That's what I've done for you already for uh, Neptune, Uranus, Venus, and Mars. I've gone through, I've done the one click alignment. I've made a red stack, a green stack, and a blue stack, put them in a group, and that's what those files are. So I've been filling, giving you time to download and upload into Afterglow. Let me spread you all out. Have you all done that now? Did you take advantage of my blathering to good?
Working on it.
Yes, sir.
Working.
Working on it.
Do I need to blather more? No one's ever said yes to that, so be careful. Okay. I am sharing, right?
Yes, you are.
Okay. So when you upload it, in case it wasn't, I didn't give explicit instructions, but you go to Open Files and you upload it to your workspace. So you go to your workspace and there's an upload. And the other places you can't upload to, but you can upload to the workspace. Okay. So you upload it and then open it. Now, let's start with Uranus and Neptune. We'll double back, excuse me, we'll double back to Venus and Mars because they're kind of special cases that I want to tackle today as well. And if there's time, we'll start to set up the radio stuff for Module 1B and 1C. How about your pick? Yeah, I'll do Uranus because it has more moons, and that will help when I show the stellarium comparison. But I prefer Neptune. It's pretty. With it's one large moon Triton right next to it. You get this great color contrast. But anyway, pick one or the other. Everyone's picked their favorite. Okay. So I'm doing Uranus here. So here's the Uranus stack. I guess I didn't load it in. No momento. B is in, the R is in, the V is in. So yeah, the combo. Okay, and I haven't colored these yet. So this is a group that has 3 images. Zoom into your planet and then color the B image blue. The R image, I'm going to color that red. And the V image gets colored green. And unlike with our really bright stuff, where we had to use H alpha, O3, and U because that cut down on the light coming in, these are faint enough that we can use the broader filters. We can expose for longer. I think the Uranus exposures are like a second instead of like 0.03 seconds. And the Neptune are like 7.5 to 15 seconds. That's why we're going to have stars in here. Anyway, you do those, put on the colors, and it should look white because the default setting is the percentile. And we can just lock that in. Come over here to display settings. Under color composite, let's do percentile first. Just link all layers percentile. And then they're all controllable through the same. Let's see, I assigned it. It's the B layer. So now the B layer has all the display controls. So I'm going to hit bright target, which I was already in. And actually, I'm going to up it all the way to 100% because it's at 99.999. But the 0.001% of the pixels, they're all here on Uranus, and they're all being, that's the saturation level. So I'm going to just up it to 100. So they don't, nothing's saturated except that brightest pixel in the image there. And it looks white because we're in percentile mode. It takes the brightest thing, in this case Uranus, and makes it white. Now, if you happen to have a bright star in your image, Uranus will have some color with respect to it. Sometimes that happens, or Neptune. Okay, now we want to go, everyone here? Everyone good? Okay. Now we're going to go photometric. This is their first introduction to that. And the first thing you need, photometric, what it's going to do here, just to show you, and you could do this, go to default preset and zoom out. And it'll look messy, the flats are imperfect. And so we got some that's out of focus dust. But the point is, okay, we got some moons around Uranus here, but also farther away we have stars. There are stars in the image, and we can use them to calibrate. But we can't use them to calibrate if Afterglow doesn't know what's what. And if you move your cursor around and look at the RA and DEC down here, it's just zeros. Because in the individual images we acquired, no one of them went deep enough for Skynet to attach a WCS. You have to have enough stars. And once you do, Skynet says, okay, I know where that is in the sky, and you have a world coordinate system built into the image. We don't have that. But now that we stack 30 deep in each filter and beat down the noise, there are enough stars, and we can attach a WCS. And that's what we're going to do next. So if you come over to the bullseye here, click on this, and let's see, for you, it probably looks like this. Let's just let's just start with the red one. So I'm going to go and grab Uranus red. Some of you are going to grab Neptune red. And we'll start just by calibrating that one. And you can't do multiple at the same time, but sometimes it's easier just to do. The red one usually has the most stars in it. So red, plate solve. If you go down to the red layer, see the show extraction overlay? There are the stars in the red. See, if you zoom into any one of them, there's a star there. And so these have been extracted. These are the ones that were extractable from the image. And last thing you want to do, very important, is you press this button here, extract values from current viewer. And mine didn't change because I did this just a few minutes before we all met to remind myself. If you don't press that, it'll search the whole sky. And it could do it. It takes a while. But when you do that, it goes to the FITS header. And in the FITS header, it says where the telescope was trying to point. It's not precise. You can't point perfectly, but at least it's somewhere in this image. And that gives it a starting point. It kind of spirals out. So if you start with where it was trying to point, it should just be like that. And I'll hit submit. Again, red image, plate solve, extract values, submit, and it should be very quick. Yep, successfully found a solution. So now when I move around, you can see I do have RA and DEC values down here, as long as my cursor's on the image. Okay. And you could do it for all three, but I'm going to show you how to copy. So now select all three of your images, the red, the green, and the blue. Go to copy, because remember, we've already aligned the blue and the green to the red. So, I pick all three images. I select copy, and I pick the red as the reference, and it just copies the WCS over to the other ones. So now if I go to the green one, it has coordinates. I have the blue one, it has coordinates. And sometimes, like in the blue, you might not have enough stars, particularly if it was a bright sky, the moon was up. You may not have enough stars in the blue bands. So that's why I always start in the red and copy. Does everyone have WCSs on all of your images? Now, when we go and start doing deep sky stuff, it should already come with the WCS on it. Because those are going to be 80-second exposures typically. And so you'll have enough stars that Skynet can do the WCS. Is that a question, Jim?
Yeah, is it differentiating the moons in there too?
Yeah, and so that's a great question. If you look here, it source extracted the planet, some of the moons, and also some points on the diffraction spikes. Actually, that's a moon, that's a moon, that's a moon, and that's a moon. And these are just points on the diffraction spikes where it got confused. And so we've added in this image let's go to the red image. Oh, and I should say, if you haven't done this, if you go over to the gear symbol, sync orientation, pixel, sync display settings, that way when you go from one image to the other, it automatically repositions everything for you. But anyway, in the red image, yeah, we got the planet, the 4 moons, and some extras on the diffraction spikes. Fortunately, the WCS solver can deal with a few identifications or extra identifications. It's able to look at this and say, okay, I can't match this stuff, but I can match the rest. So here's your solution. And it's good. All right. Well, we can go back to the main level here. So click on the group and it has the RGB combination. And if you come back here to display settings, those sample stars are gone. So now now that we have coordinates on our image, Afterglow can figure out what star is what and use that to set the levels. So go to Color Composite Tools, Link All Layers Pixel Value. So instead of using the percentiles, it's going to use the actual pixel values. Now for mine, my histograms look pretty similar, so it didn't change that much. But suppose I image the green filter twice as long, then you'll have twice the pixel values in the green, and so this image would be green. By linking at pixel values, it's just whatever pixel values are in the image. If one of the three layers has more, it will be more that color. It's meaningless. It hasn't been calibrated yet. Okay. But first you link at pixel value, and then you go down to photometric calibration, the fourth one down. And it will try to fill it in.
Well, my computer crashed on me during this meeting, so I've kind of.
Oh, wow.
Oh, very sad. Oh, okay. That wasn't for us. Okay, red. It will usually fill it in, though. I think since I did this one before the meeting and then I deleted it and then I reopened it so I can do it again, it's forgotten. So you have to reset it. Red, green, blue. Reference layer doesn't really matter that much. It actually doesn't matter at this stage. And I'll explain these in a second. Now, it will have the numbers in from the last time you ran it. So don't just think you're done. You have to press this button to measure the 0 points. If you scroll down, you can see the status bar. That went really quick, actually. And I got the same values because this was the last one I did. But red, green, and blue, I measured the 0 points. And these are the relative layers. These are the factors that you have to multiply each by. Well, they're magnitude versions, right? They're minus 2.5 times the log of the multiplicative factor that you need to set the levels correct. So it's the multiplicative factor, but in magnitude space. Okay, and once you get that, well, let me explain these other buttons here. Extinction, this is a cool feature. We won't use it here, but once we start doing star forming regions, you can correct for dust along the line of sight. We can just correct for it in the layers. A field may look very red, but it's only red because of all the dust between us and it. And so I can do the correction here and see those stars as they would be seen if there's no intervening dust. So we'll use this feature in like module 3 and 2, I think. Yeah, 2 as well. This one here is kind of subtle, white balance. It's the definition of white. And you have different options here, but pretty much always in the MWU curriculum, you just leave it alone. If you have a black body that peaks in the blue, that's what the human eye sees as white. The human eye doesn't see equal levels of red, green, and blue as white. They see a black body peaking in the blue is how we see white. And so this makes it white look white for the human eye. Anyway, go ahead and calibrate your colors. So change the shades because the levels are different. And if I hit bright target now and zoom in, and the very center is white because, again, that saturation level just got reset to 99.999. I'm going to up it to 100. So only, so it doesn't digitally saturate. And that's the color of Uranus, true color of Uranus. So instead of white, which we were getting percentile, and that's, as close as we're going to get to how the human eye would see it if the human eye were looking at it. Now, if you did Neptune, this year it came out a little greener. You may be looking at your Neptune, if you did Neptune, and said it's greener than your Uranus. It should be a little bit bluer. The reason it's not is Neptune is close to the sun. So when we observed it this year, it was low in the sky. The sun set, Neptune was right behind it. You're looking through a lot of atmosphere, and the atmosphere reddens, takes out the blue. And so this year, Neptune came out a little bit greener than Uranus. Let me pull up the actual, this was in the email I sent, but I have it in here somewhere. Here it is. I did this last year when they were both high in the sky. And you see there's Uranus and here's Neptune, a little bit bluer. It's not as blue. It's not blue crayon blue. I tell my students when you're in grade school, coloring the planets with your crayons, you use the green crayon for Uranus and the blue crayon for Neptune. And it's actually closer to green than blue. The reason we use that blue crayon, I think I have it in this, the famous Voyager 2 pick. I think I have it in here somewhere. Here it is. When the Voyager 2 team made this, some engineer arbitrarily set the red, green, blue colors and got it way too blue. So everyone thinks Neptune's this blue, and it's not. It's whatever I just had up. I guess I closed it. It's that blue. And for you this year, it's actually a little bit less blue because atmospheric reddening. All right, but we're not done. Everyone get this far? And I should say, if you export it, we'll do the moons in just a second, but if you export image as JPEG, it will do subpixel interpolation. Now, if you're on a Mac, you have to open it, not in the, I'm not a Mac user, so forgive me if I don't get this right, exactly right. Not the generic pixel viewer, but your Apple picture viewer, and it will do that subpixel interpolation, giving you kind of the nice smooth blob. It's not like sharpened or anything. There's no additional resolution. It just kind of, you won't get the blocky pixel thing. It interpolates it. So we're set up to do that, but you have to open it in a picture viewer that supports it. Okay, let's take a look at the moons. So you go from bright target, just hit default preset, and zoom out. And actually, for the moons, it's good to use the mid-tone stretch. We're in linear stretch right now. You can see them there. Here they are. They're digitally saturated. Go to mid-tone, hit that default again. It's a little bit better. And then you want to up that with mid-tone. I think we talked about this before. You're adding an extra control. You have the background level, you have the saturation level. Now you have this thing in the middle called a control point. You can move it around and make things brighter and dimmer. All these other modes, linear, log, square root, hyperbolic, arcsine, it puts all the definition on one side or the other, the bright or the faint. You can see the bright details and lose the faint stuff in the image, or you can see the faint stuff and digitally saturate the bright stuff. You can't win both. Mid-tone lets you have your cake and eat it too. You get to see the faint stuff without saturating the bright stuff because it sticks in this third control point. And so I'm going to increase this. It's at 97. Let's try 99, 99.5, 99.9. There we go. 9.95, 96. I just kind of up it until I'm starting to lose moons. So I'll go back to 99.96. And then, yeah, the center of Uranus is digitally saturated, so it'll appear white, but the outskirts, you got the correct green color. And the moons, they are redder than the green planet, and that makes sense. And if any of you are doing Neptune, anyone doing Neptune? You want to share? I'll stop my sharing for a second if I can find my controls. Let you share for just a second, or anyone who got Neptune and Triton. Oh, I think I have to set yeah, okay, now, if you got it, you can share it.
Yeah, okay. I'm not sure if I did everything right, but I'll show you what's on my screen.
Okay,
So,
okay, great, and zoom in.
yeah. So I think I came in a little late, so I may not have done everything right, but I think I tried to follow through
Yeah,
here. I don't have Stellarium up, so I don't know what's what.
so the one really close is Triton. The other
Okay.
two are just random background stars that happen to be close to
Oh,
Neptune.
these are stars. Oh,
Yep.
interesting.
Yeah, normally, I was actually surprised to see the other ones there. Normally, you
Yeah.
just see Neptune and Triton, but occasionally, background stars can photobomb. And you just
Yeah.
happen to get the two bright stars in the image right next to the planet, same brightness as Triton.
Yeah, yeah.
Triton's always easy to find. You don't need Stellarium. It's that close thing right nearby. And, as I said, normally Neptune's just slightly bluer than it is this year. So you get a nice contrast. Here, I'll take the share back.
Yeah. Let me see. Good stop.
I'm sure I have uh, one as well. Yeah, here we go. This, I've already exported it. That's not the best one ever. But when you export it, it does the subpixel interpolation. So Neptune and Triton. Probably got a better one down here somewhere.
Yeah, you're not sharing right now.
Oh, shit, sorry. Thought it was. Let's see. Maybe this, I guess this is the best one I have. So kind of similar. So this is after you export and it does the subpixel interpolation, make it look a little prettier, but Neptune, Triton, that one's fairly green as well. That may be the one from this year. I don't know. Anyway, last bit is Stellarium. So let me pull that up. And with Triton, it doesn't matter. It's always the closest one. I guess technically you could get a star closer, but it's rare. Stellarium, F11. You want to set your time zone to UTC, so you hit the location window. Here, I'll close it in case you missed that. The first one up here, location. Set the time zone to UTC or UTC 0. Turn off the ground, turn off the sky. It's these two right here. And then hit the telescope icon that orients the sky the same way as your image. And then we're going to search on Uranus or Neptune if you want. Zoom in. If you zoom in too close or too fast, see, sometimes the picture of the planet disappears. You got to go in just slow enough. And looking at that and this, there's always a flip. And so I'll come down here. Unfortunately, when you do the flip and you export, it doesn't remember the flip. And so you have to flip it in the exported image as well. But there we go. Titania. Oh, 1 second. I forgot the time. That's remarkably similar, but no, 1 second. So if you click on any layer, so we're going to go to the image info, and it doesn't have it for the group. You got to click on one of the layers, and you have the time there. So in Stellarium, this one, the second one is the time, and this image was taken January 24th at 0:56, and I've lost Uranus. Go back to Uranus. Okay. There we go. And I've flipped my image now. Put the full color one back up, and there we go. Titania, Umbriel, Ariel, Oberon. And it says Miranda's right here. Now remember, ours is blurred out because of atmospheric blurring. Your planet will never be as small as depicted in Stellarium. But there's a chance that this little kind of almost brownish love handle is Miranda, but I wouldn't bet any money on it. Okay, so that was our introduction to photometric color calibration. Again, going from assuming the brightest thing is white to actually getting close to correct colors. Questions about any of that? Always remember to save your work as well. Once you're happy with it, save it, or else you have to do it again. And of course, there's the export.
If you zoom out a little bit and and squint your eyes, it might be.
It might be, yeah. Like
It
here,
might. I think,
I look at it at this
it's
scale,
really, you
and
got
I
me
think,
convinced.
yeah, if I go in too far, I don't believe it
Yeah.
anymore. If I come right about there, I think that's Miranda. Yeah. So maybe a fifth moon. And all the background stars are the appropriate color too. Most of them are just kind of these are faint red stars, and so they have kind of a reddish hue to them. Occasionally you'll get one that has some color to it. Yeah, the flats weren't great in this one. You can really see out of focus dust, but still. The goal here is color, right? As I think I described last time we met, um, if you're doing planetary astrophotography, it's a totally different setup. You have a video camera on, you collect thousands of images, you use specialized software to get rid of most of them, keeping just the atmospherically perfect ones, and you can do something much sharper, much better. We don't have that kind of setup, so the point here is to do color and to learn the skills, the afterglow skills that they'll use throughout the course. Okay.
So before
Yeah.
you leave this image,
Yeah.
like I can see it's pretty much the same orientation. So what moons are what there?
Let's see. It doesn't save the flip
Uh,
in afterglow, so you have to flip it again. So let me do that. Okay, so what we have is Titania, Umbriel, Ariel, Oberon, and this right here might be Miranda.
maybe I got the wrong day here.
In Stellarium?
Yeah, yeah. I can look at it again.
Okay. Yeah, yeah. Your afterglow picture should be the same because we're using the same data. So, oh, it could also be maybe you didn't set the time zone correctly. Set to UTC. Are you off by just like a little bit?
No, what happens is when I should set the time before I set the day because what happened was I started at 124 and then started jacking with the hours and minutes. And by
Oh,
that time, I had flipped over to the next day. So,
yeah.
anyway, I think I got it now. Thank you.
Cool. Okay, let's do our two special cases. Let's do Venus, and we'll save Mars for last. Venus should be pretty easy. Venus is purely photometric, sorry, percentile color combination. No background stars. It's, Venus is the brightest planet, so we're not gonna have any background stars. And normally you would just do this through the photometric, sorry, brain not functioning, the percentile color combination. The problem is being so bright, sometimes it will saturate one of the filters. Now, so here's the U filter, which is our blue. I put my mouse on the brightest spot. Look at the number of counts down here. 35,000, not saturated. That's great. The green filter, I don't know why it resized. 43,000 counts, fine. But H alpha, clearly we saturated. I wonder why it's doing that. This whole region saturated. And this was a 0.03 second. We can't go any faster because the shutter needs time to open and close. So you may think all is lost. We can't color combine this one. But there's a little trick I'm going to show you now. So you can start by trying, like we can color the H alpha red, the O3 colored green, and the U band color it blue, and go to the combo level. And it looks, wrong because that red band is saturated. It's wrong. And here's the trick you can do. And Venus isn't always this bright, so you won't always have this problem. But turn off the red layer, take the green layer, right click, duplicate it, and then color that red. We're going to use the green layer for both the green and the red. And this works with Venus because the cloud tops are white and yellow. And white is an equal amount of red, green, and blue, and yellow is an equal amount of red and green. So we can actually just use the green layer as the red layer. So for this copy, I'm going to color it red. So again, we hit the eyeball to turn off the H alpha red layer, made a copy of the green layer. What I color it? Color it red. Okay. Something's not right. Red, green, blue, red. There we go. I guess I just had to force it to reopen. And there we go. Venus, its cloud tops are a mix of white and yellow white and something like that. The little hack, in case we do saturate the red filter, which we did this year for Venus. Again, I can export it, get a pixel interpolated one. Looks pretty. And I updated the instructions to let the user know that you can go deeper. Normally we say something's less than 20 degrees above the horizon, give up. But sometimes with the Venus, you got to go down to 15 or even 10. And this was like around 10 and it worked. So I updated the instructions. In a number of places, I updated the instructions based on the experience. They're getting pretty polished now. Any questions on that little hack with Venus? Y'all get a pretty Venus? Matt did not. So can we help you?
I mean, it looks better than before I copied it, but it still doesn't have that green where your pointer is pointing right there in the crescent part. It
Yeah,
still looks pretty blue. So you
yeah.
were
I did
red.
the same thing. Open each one individually. I think it may be something with the copy that it doesn't auto load, and so you're gonna have to force it to load and then go back to the group layer, and it should.
Uh,
I just learned that right now. So yeah, when we made the copy, it apparently didn't load it in, and so you had to force it. Did that do it?
what did you change any of the modes? Is it just in linear?
Yeah, I think it's in linear. Yep. In fact, I didn't even. Oh, I may have not even. Maybe you have to link it. Link all layers percentile. That's the default. Uh, it displays in percentile, and it worked without me linking it actually.
Hmm.
Dan, when I did my copy of the H alpha, it gave me a big tri or diamond shape area of red that didn't look anything like Venus. And when they merged together, it was just a big glob. So
Oh,
I deleted it and recopied. Now it's fine.
okay. And you copied the O three, right?
Yes.
Yeah. Okay.
But then when I colored it red, the Venus shape was a big giant diamond of
Huh.
saturation.
Yeah.
And it didn't even match the overlay with the planets. It looked really weird.
You may have to actually link all layers percentile to get it to work, and it can hit linear bright target again. The copy a layer functionality has not been thoroughly tested because we seldom ever use it. And so maybe there were a few hiccups there, but I was able to get it to this. Anyone still?
Yeah, I deleted that copied image and then I recopied and it looked like Venus then. So
Okay. I'll just pause and see how everyone's doing. Anyone need any help? Anyone stuck? Okay. Let's do Mars. Go up to Mars here, zoom to fit. There it is. And I'm gonna color H alpha red, O3 green, and U band blue. And this was taken
so
on.
I just found I that when I removed that one copy, I have it put it outside of all of my work, but I found it
Yeah.
if you wanted to see it.
Okay. Uh, Stop share. Okay, go ahead.
So can you see that?
Hasn't ported over yet. It says you're there we go. Okay. Yep. Oh, it's yeah.
That's where Venus was located, and that's how the copy looked.
Go to display
The
settings.
default preset, isn't it?
Yeah, yeah. It's probably on the
For
wrong
bright
preset.
target.
Yeah, so go there and bright target it.
Oh,
There it
okay.
is. And so no, but you raise a good point. When we made the copy, at least for you, it came up in a different scaling than the others. And so
Mine did that too.
okay. So linking them, um, so this has been useful. I'll check my instructions in the manual because I added a little bit about this trick and I don't want people to get stuck. So you may have to actually go through the process of percentile linking them to force them to be this on the same scaling. Okay. I'll share again and we'll do Mars. Ah, Zoom window will move. Oh, okay. Okay. Mars doesn't work for either percentile or photometric. Doesn't work for photometric because there's no background stars. It's too bright. And it doesn't work for percentile because the brightest thing in the image is not white. The ice cap's white, but it's not the brightest thing. The red surface is the brightest. So it's trying, there's all sorts of colors. And so the kind of the bright end of this, it's making white. Here you can see the bright spot and it's white, and all the other colors are relative. And so that doesn't look like Mars. Sometimes it's better than other times. Um, Before we do it, I think I have an image or two could put in context. Here we go. This is Mars at closest approach every 2 years. Here's 2025. So this is kind of the farthest closest approach that you get. 2018, the thing would be twice in 2035, it'd be twice as large and you'll see even more detail. And then I got this one here. You can see it very quickly is fading. Now I took mine on the 13th, which I think was the day of closest approach. So it's as good as it gets this year. But even if you're a couple months later, you're rapidly losing detail. Once it gets down to about this size, it's going to be looking like almost Uranus, right? Okay. So you just have a window, a couple months every 2 years to get detail. And here's a picture. It's in the, and we'll get here in just a second, but this is from 2 years ago. And here's Stellarium, and here's the image I got, and you can see the features match, and we even have an ice cap here. Stellarium leaves out the ice caps usually. So let's see how good we can get it this time. Okay, so the way to do this, you have to do it manually. It's just by eye because we can't use either technique. So you start by going to color. You pick the dominant color. And I forgot to mention this with Uranus and Neptune. It's a really small effect, but it helps if you link to the dominant color. And with Uranus and Neptune, it's like green or blue. With Mars, it's red. So we're going to pick red, and then we're going to link all layers pixel value. Okay. And this again, yeah, it looks a little bit closer, but it's arbitrary. If I image the blue filter twice as long, this thing would look very blue. It's just I picked my exposure times fairly well, such that it's fairly close in color. But what we can now do, we've linked it to the pixel values. We're just going to adjust them. Maybe leave the red in place. And I look at this, it looks a little green to me. So I'm gonna, right here, not over here, but right here, switch to the green layer. You see it's linked to the red layer, but you have a scale here. And it looks a little green, so instead of 1, let's try 0.9. Oops, I did 9. 0.9. So here's 1 again. 0.9. 0.8. It's pretty good. It has maybe a faint hint of blue, so I'm going to switch to the blue layer. Drop that a bit, maybe 0.9. 0.8, 0.85. I drop them both. Anyway, it's just by eye. So once you're happy with it, we'll export it. It looks good when it's not zoomed in, right? The subpixel interpolation actually does a nice job here. Let's see, I'm going to go to edit. There's always going to be a flip. And then I'm going to rotate the ice cap to the top. So let's go to Stellarium. Well, let's get the date and time. So click on one of the layers and then the I for information. So this one was the 13th at 3:57. Then I'm going to go to Mars. And remember, you got to be in equatorial mode for it to be the right orientation right here. So I could have gone maybe just a little bit redder. So it's not perfect. In fact, even this year I had better ones than this. Maybe it was bad atmosphere at the time, but the shading does match. You see this dark region here. That's right here. We have an ice cap on top. Stellarium has kind of uses minimal ice cap imagery for its reconstruction. These dark regions down here are there, the bright band across the middle. So, the features match up. Again, you can really see it if you don't zoom too far in.
Dan, can you
Are
explain? Oh, go ahead. Go ahead, Seth.
are the moons of Mars just too small for us to ever see them?
I keep trying and I've never succeeded. They're real close. Let's find them. Deimos and where's the other one? Oh, Phobos is behind, but here's Deimos. It should be right to the left. So let's see. I'll go and let's do that same orientation. So there's a flip of some type and rotate the, oops, I keep flipping it. Reset orientation. Rotate. There we go. Okay. So given this orientation, it should be right here. So let me go back to the base layer. Should be kind of right there. I'm going to increase. They're just faint. And
Yeah,
Mars is bright.
they're really faint. I think most people have to use like an occulting disc on
Okay.
Mars in order to get a view of that. It's a pretty big challenge with this size telescope, even, you know.
It should be
Thanks for indulging me.
right here. I'm gonna put my finger on the screen. I almost fooled myself into thinking something was there, but nah, I don't see anything. I'd love to see it someday, but yeah, I agree. We're just not set up for it. I mean, they saw them in they discovered what, 1801? It can't be that hard. But yeah, we fail. But we got that. It's not bad. Now, if you do this, outside of that window, which it's real convenient, it's lining up with the start of the semester every other year, and right when I'm doing planets. in the spring. So every other year we get some features, but on the other years or the other times when it's too small, it's all blurred together, and percentile combination will just make the whole thing white. It'll be a white blob, and you can adjust manually to make it a red blob, but you're not going to see details.
Which is the good year? Odds?
Yeah, this year. Yeah. Well, any questions about any of that?
So did you say you
I think
updated
my
the-
question. Oh, go ahead, Jim.
No, well, I was just going about the instructions for this. You say you updated the
Yeah, module
this
1A and 1D have now been updated.
And that's
Though
okay.
I'm going to check on my V. It's small things, you know. I've taught it now for a third time, and then I sit down, and after I'm done, I go through and say, "Oh, I can improve this," or "I've learned something new." So I'm trying to update them all. I'm working on writing up, for those of you who are in the radio group, I'm writing up the module to go with that right now. Anyway, we have 10 minutes, 9 minutes, and oh, Matt, did you get your question?
Well, I think my question is about the rotation. So if you use how that works with Afterglow, if you use the rotation in Afterglow and then hit the landscape export image as JPEG, does it keep that, or does it just, okay, that's what I thought. So when you actually do the rotation, you were doing that in your editing software? Okay.
Yeah.
All right. That's what I thought. I just wanted to make sure I was tracking with you, because I was looking down and not looking at what you were doing.
Yeah, I did it in the editing, and then I did it again here in Afterglow. Ideally it would remember, and that's on the to-do list. It just right now Josh is focused on Skynet 2, so there won't be any Afterglow improvements this year unless they're really minor. And actually looking at this, it looks, the ice cap came out a little green. It usually comes out a little white. So, maybe even take out a little bit more green. I think that's even better. Anyway.
Yeah.
Okay.
So another, like, a follow-up question to this, it seems like you're basically using the landscape export as JPEG, but the camera does hold whatever orientation and zoom you have, but you prefer not to use that because of the resolution, or
Right. So no, these are great questions. For something like a planet here, totally fine. You want to frame it up. This does just a screen capture of this area. And, it'll come out exactly as you'd set it. It will be pixelated. It won't do the subpixel interpolation.
I see. So you don't, okay. So that's an advantage of doing the full res, full image.
Yeah, let me pull up here it was. This had different color scheme, but you're not really gaining anything. You're losing the blockiness. So yeah, there's an advantage there. The other reason why you do that, it's for later on when we do the deep astrophotography of large fields. You're going to want every pixel. So yeah.
That helps. Thanks.
Because if you zoom all the way out, what's being displayed here is not all the pixels, because they won't all fit. So it's like every other pixel. And so if I export this and then zoom in, you see I've lost definition.
Yeah, for sure.
Okay.
All right.
Well, so 6 minutes. I don't think I'm gonna start radio this time, but next time we'll do radio. We got module 1B and 1C. We'll do them together. One, just to kind of set it up and remind you, because a lot of you worked on these in the development phase. 1B is the radio moon, and 1C is radio Jupiter. So this is all part of the solar system package at the beginning of the course, which is really just an excuse to learn all the tools. And there's lots of good stuff in here. we spent a lot of time talking about how the radio telescopes work, how radio image making works. And I'll overview some of that stuff kind of briefly next time. And so what for the moon one, what they do is they image the moon at 2 different days where the phase is different. And a calibration source. In the radio, you always have to image a calibration source when you image your primary source. And it just comes out as a blob. But they measure the brightness. And even though the phase of the moon is very different, like we did new moon and then like 20%. And so if it, the question that the moon team has presented, what are we looking at? We're detecting something in the radio. Is it reflected sunlight or is it intrinsic thermal emission? And so they image at 2 different phases. And if it were reflected sunlight, the radio brightness of the moon would change dramatically. And it doesn't. So it tells you it's thermal, and they go through the process of photometering it. So they learn aperture photometry in the radio instead of in the optical, where it's normally taught, but it works out nicely. They learn calibration. So they aperture photometer their moon, and they aperture photometer a calibration source. So they can convert it into Jansky's, which becomes an MKS unit. They learn the Rayleigh-Jeans equation for thermal emission in the long wavelength tail and calculate temperature. And since the brightness isn't varying, they're measuring the temperature of the moon. And so that's the one module. And everyone picks one or the other. The 2 modules are very similar. And so I have my teams half pick one, half pick another, and then they're going to review each other's stuff. And the Jupiter team, they go through the same process. They image Jupiter. Jupiter's much fainter. In fact, we do the imaging at night, so we don't get sunlight reflecting off the struts, messing up our image. And they photometer Jupiter in their calibration source and go through the process of calculating its temperature if it were thermal emission. And they get something like 1800 Kelvin. And Jupiter's about 100 Kelvin. We're 280 something Kelvin here on Earth. So Jupiter's got to be, they're farther away, 5 times farther away, got to be colder. They're getting a higher temperature. And so that means that it's not a black body source. So they're very similar. They learn all the same techniques, but then in the end, they're asking different questions. With the moon, is it reflected light or thermal light? It's thermal light. With Jupiter, is it thermal light or something else? And it's something else. It's synchrotron emission from electrons spiraling through its massive magnetic field. So I had a few minutes, so I figured I'd just set that up and tease next time. And I'll give you some of the background stuff on radio for those who are new, and then we'll try to do the temperature and photometry exercise. Let's see if we can do it all in one meeting.
Dan, if I can ask just a couple of unrelated questions.
Sure.
I think you mentioned a couple times about emails you're sending out. I think I might not be on whatever list you're sending to.
That could be.
So
Because
I'm
you're
asking to be added.
Yes. I should set the thing up as a listserv. I haven't. So I have a list of emails. Every semester I send out an email saying, do your surveys and sign up for the next semester. And that's when I update my BCC list. And so you'll be put on it. I'll try to remember with the next time but after that, I just reply to that throughout the semester.
Yeah. That makes
So
sense.
you got left off. I really need to set up a formal listserv though. I'll put on my to-do list and I'll try to remember to add you for the next one.
Yeah, no worries. The other thing was that my students are going through and doing their first labs. They're due in a couple days, and one of them was having trouble, but when they put in the name of the telescope, prompt 5, or whatever, that WebAssign was saying your answer cannot be understood or graded. Now,
No numbers. Doesn't like numbers.
oh, so should they just type in prompt or
Or
whatever?
they can spell out 5. I mean, it's
Okay.
I discovered the same thing. It doesn't like special characters, yada yada yada.
That's all good.
It's
That
a new bug, I should say. It used to be able to accept it, and it will once I file the bug report.
okay.
I'm
That's
doing
it's simple
MWU
enough,
revisions.
just so I know what to tell the students. That's
Yeah.
an easy fix.
It
Okay,
will be
thanks.
fixed in time, but it may be a while.
Sure.
And what,
Hi. I have a also an Opus question.
yeah.
When you on the exposure efficiency, they should be putting in the generic 16-inch telescope. Just a question. A lot of them forgot to do that. Does that affect just the quality of their images, or could it even affect like the time in which their images are returned?
No, it won't affect the time in which they're returned. All that does is it lets you, so, we're a very heterogeneous system. We have all sorts of telescopes, volunteer telescopes. Some are, can get to deep limiting magnitudes quickly, and some you have to expose a lot longer to get that deep. So in Opus, we do this less in MWU. In MWU, you're picking a telescope and using it. In Opus, we give them exposure times, and that's for a generic system. It's actually the historical average of prompt 5, but the current efficiency of prompt 5 is detached from it. Anyway, it's kind of it's a generic 16-inch telescope in Chile. And so all the observations are designed for that, but they're picking a whole bunch of telescopes. And if you pick generic, what it does is it rescales the exposure time. For whatever telescope it ends up going on, it will rescale it automatically.
Okay, thank you. That's really helpful. And one more question. They did the pre-survey.
Thank
Is
you.
it, yes, is it still possible to receive the $500 stipend, or is that kind of timed out?
For Opus, no, we're in the last year, and so nope, that's still good. I will issue. So with MWU, we're done with I know all the payments haven't gone through, but there's no money for this year. But Opus, there's still the final year of money, and so there'll be the $500 payment. Those will be dispersed next summer.
Oh, wow. Okay, thank you.
Yep. And we will be putting in another grant this summer, though I'll get started on it in March for $2 million to NSF, which may not even exist in its current form. So, we'll see how things shake out. But we're going to do an NSF IU's 2 million, and it's going to be about the MWU curriculum. Not so much Opus. They've already given us 2 million for Opus, and we've done great things with it. Trained up 3 times as many institutions. The education research results are astounding. But we can't ask for more money for the same thing, so it will be focused on those willing to implement MWU. And kind of the framing will be, a lot of our introductory courses are an intro course in a lab, and Opus works as that lab. But if you want to go to the next level, it's replace the whole course, the whole lecture course with an exploratory course. And the argument, you've heard it many times from me before, it doesn't really matter what we teach in our intro astronomy courses. For most of these students that we teach, they're not going to become astronomers or even take another astronomy course. So it's not about building scaffolding. It's not about that. It's more about the affect of things. Can we inspire them to become scientists or at least have a positive STEM attitude? So the desire to teach everything in the textbook really is irrelevant. They're going to forget it all in 10 years anyway. If you have a student come up to you in 10 years, say, oh, I remember this about your course. You're amazed that they remember even one damn thing that you taught them after 10 years. And so instead, it's about giving them, let's teach them what science really is by giving them real investigative experiences. And so the way we're going to frame the proposal is, Opus is if you want to replace your 1 credit lab, MWU is if you want to go full investigative in your, abandon the lecture and just explore the universe through actually doing it. Anyway, that's kind of the plan, the beginnings of a plan for the proposal.
That's really exciting.
Yes, I clues. Teaching this season, what was that? Teaching the oh, it's so big. Teaching the seasons to students who don't care is the hill I will continue to die on. Yeah. Yeah, I'm so tired of that hill. So I'm glad someone's going to defend it, but it's not going to be me.
Yeah, the experiential learning is a really big deal.
That was a great conversation last summer at the Master Ed UNC conference that you had.
I was amazed by how everyone there was no debate really. Like, yeah, anyway, next.
Really gets to the point of you should be teaching, thinking and analysis, not necessarily a subject. It's just a way to communicate that information, that skill.
Mm-hmm. Instead of learning the results of everything that's been learned for the past however many hundreds of years, yeah, you're not going to cover everything, but some things you're going to drill down, not necessarily even deeper, just differently, because they're going to discover it for themselves. That's the idea. Anyway, we're past 4 o'clock. I'm happy to stick around and chit chat, but otherwise, I'll see you next week and we'll start ramping up on radio.
Okay, thanks, Dan.
Thanks.
Thank you, Dan.
Thank you, Dan.
See ya.
Thanks, Dan.
My pleasure.